Now that we know how to factor out a GCF, we're going to learn about our first official factoring technique. And that technique is called factoring by grouping. Now, if you recall, I mentioned that there were several factoring techniques that we're going to learn throughout this course. But we're going to try to group each one of those techniques according to the number of terms in the polynomial that we're given. Now, we'll always look for a GCF no matter how many terms we have in our polynomial that we're trying to factor. But then once we've factored out a GCF, we will turn our eyes to say, okay, how many terms now am I working with? And this technique, factor by grouping, is a 4-term technique. In other words, whenever I see 4-term polynomial that I'm trying to factor, my mind automatically goes to, hey, let's factor this by grouping. And as we can see here, we're asked to factor this polynomial, and we have 1, 2, 3, 4 terms. Right off the bat, I see 4 terms, and I'm thinking, okay, factor by grouping. Okay, so let's get started. Remember, step number 1 to factoring polynomial every time is to look for a greatest common factor. In other words, we want to look for a common factor between all 4 of our terms here. The first term is 2c. The second term is 2d. Well, those 2 terms have a factor of 2 in common. Let's look at the third term. It's minus cd. Minus cd does not have a factor of 2 in common. So therefore, 2 cannot be included in our GCF. So at this point, we don't have a common factor. Let's look at our last term, minus d squared. Again, there is no common factor between these 4 terms. So when we look for a GCF amongst all 4 terms, there's not one. Okay, so no GCF among all 4 terms. Let's begin the process of factoring by grouping. This process says that if there's not a GCF among all 4 terms, look at the first 2 terms, 2c plus 2d. Is there a GCF among those 2 terms? And the answer is yes. There is a GCF between the first 2 terms, and that GCF is 2. So let's factor out a GCF of 2 from the first 2 terms. That would give us a GCF of 2 times the sum c plus d. Now let's group our last 2 terms together, negative cd and minus d squared. Do we have a GCF between these 2 terms? Yeah, it looks as though both of these terms have a factor of d. So GCF would be d. But if you remember a couple of videos back, we said that anytime our leading term had a negative 1 as its coefficient, that it was 90% of the time beneficial to factor out that negative 1 as part of our GCF as well. So that's what we're going to do here, because our leading term in this group is the minus CD. And that minus CD has a leading coefficient of minus 1. So we're going to make that minus be part of our GCF as well. So we're going to factor a minus D from the minus CD minus D squared. And that will leave us with C plus D. So we've taken our first step in factoring by grouping. We grouped the first 2 terms together and found a GCF of 2. And when we divided those 2 terms by the GCF of 2, we had C plus D remaining. Then we looked at our second group of 2. And when we factored out a minus D as a GCF from those 2 terms, we were left with C plus D. Now we have a 2-term expression that we need to continue factoring. The first term in that expression is 2 times the sum C plus D. And the second term is minus d times the sum c plus d. Can you see the binomial GCF in those two terms? Each one of those terms contains the binomial GCF of c plus d. So now we're going to continue factoring by factoring out that binomial GCF of c plus d from each one of our remaining terms. If we divide the 2 times c plus d by the GCF of c plus d, what's remaining? Just the 2. And then if we divide the minus d times c plus d, what's remaining? The minus d. So the final factorization when we factor by grouping is c plus d times 2 minus d. And let's recap. How did we get there? Well, we started by grouping the first two terms together and finding a GCF in the first two terms. Then we grouped the last two terms together and found a GCF from the last two terms. Then we noticed we had a binomial GCF from those two terms. And when we factored out the binomial GCF, we found that the final factorization was c plus d times 2 minus d. So here we're asked to factor the expression 5x to the third minus 10x squared plus 4x minus 8. The first step to factoring any polynomial is to look for a GCF amongst all of our terms. Well, we can see that we have 1, 2, 3, 4 terms in this polynomial. Let's see if we can find a GCF amongst all 4 of the terms. Let's start with the coefficients. 5, negative 10, 4, negative 8. Is there a number that you can think of that will evenly divide 5, negative 10, 4, and negative 8? No. Now let's look at the variable parts. The variables in the first term are x cubed. In the second term, we have x squared. In the third term, we have x. And in the fourth term, we have no variable factors. So is there a common variable factor amongst all 4 of these terms? No, because the last term contains no factors of x. So there is no greatest common factor amongst all 4 of these terms. And that's okay, because we have 4 terms. And anytime I have 4 terms, I know I'm going to try to factor that polynomial by grouping. So let's look at the first 2 terms. 5x cubed and minus 10x squared. Do we have a GCF between those 2 terms? Yeah. 5 will evenly divide 5 and 10, and x squared will evenly divide x to the third and x squared. So our GCF is 5x squared. So let's go ahead and factor 5x squared from 5x cubed minus 10x squared. When we factor a 5x squared from 5x cubed, we have x. And when we factor a 5x squared from minus 10x squared, we have minus 2. Now we continue by grouping the last 2 terms together. The last 2 terms are plus 4x and minus 8. Well, 4 will evenly divide 4x and minus 8. So our GCF is 4 plus 4. Now let's divide 4x by 4. That gives us x. And if we divide minus 8 by 4, we get minus 2. And again, we notice at this point that we have a binomial GCF between the 2 remaining terms. Now, it's important to note that when we get to this part of factoring by grouping, if the binomial factor here does not match the binomial factor there, we've either done something wrong or this polynomial cannot be factored. In this case, the binomial factors do match, so they are our common binomial factor. So let's factor out the common binomial factor of x minus 2. And when we divide 5x squared times x minus 2 by x minus 2, the x minus 2's cancel out and leave us with 5x squared And when we divide 4 times x minus 2 by x minus 2, the x minus 2's again cancel out and leave us with plus 4. So the final factorization of 5x cubed minus 10x squared plus 4x minus 8 is x minus 2 times 5x squared plus 4.